Hi guys, welcome to the Information Technology program here at SIIT on YouTube and iTunes. We've got another web clip, another tutorial web clip, one of our classes, and we'll be doing further ones in various classes just strictly for tutorial information, not intended to replace any class time, but we hope you find them useful. So in this clip, we're going to continue our discussion on IP addressing. And the last thing that we talked about was the various classes of IP addresses. And we noticed there are actually 5, and we limited our discussion to A, B, and C. We said we could tell what any address was or what class it was simply by looking at the first number of the address, seeing what range it fell into to identify its class. Now, the class of the address tells us additional information, and the additional information relates to how an IP address is structurally divided up. Now, any address is actually divided up into 2 subparts, and the subparts are the network portion and the host portion. So for example, for this Class B address, the first 2 numbers make up the network portion, and the second 2 numbers, or the last 2 numbers, make up the host portion. What we mean by that, when we say the network portion, these 2 numbers identify the particular network that this IP address exists in. The last 2 numbers identify a particular host within this network. And so it's important to see that structure. Now, what I've divided up here, how I've divided this address up, comes from the fact that it's a Class B address. Each of the 3 classes has its own way of dividing the address up into network and host portions, and there's a definite pattern to it. So if we look at each class one at a time, what we see is, first of all, for Class A, we could have an address like that. The network portion of this address is the first octet, and only the first octet. The remaining 3 numbers, or 3 octets, identify a particular host within this 10 network. If I look at a Class B address, like the last example, we said that the first 2 numbers identify the network and the last 2 numbers identify a host. So here we have 172.16 identifying a particular network, and 10.5 identifying a host within this network. Likewise, if we look at a Class C address, we should be seeing the pattern forming here. In the case of a Class C address, the first 3 octets identify a particular network, and the last octet identifies the host. Like that. And so we see the pattern of the way that this works. Now it's important to understand this, not only what class the addresses belong to, but how this division is made for each class. Part of the reason for that is there's implications that this division has. For example, if I look at this address here, because I only have this octet to use for networks, and I only have that range of numbers for that class, that means I only have that many possible networks for a Class A address. On the other hand, if I look at these three octets that make up the host portion, it's the combination of the three, not any individual number. Because each of these numbers can be 0 to 255, I have a total number of combinations here, possible combinations, just over 16 million hosts within each network. If I go down here, I have 2 octets for network. Each of these, this number here can be in the range 128 to 191. And here, I have this number here, could be anywhere from 0 to 255. So the number of combinations I have there is actually 256 times 64. And so what that gives me is 64 times 256 total possible networks in Class C. I also have 2 numbers here rather than 3. In combination, each of these can be 0 to 255. That gives me just over 65,000 combinations for hosts. So that means that I can, for any particular Class B network, that network will have just over 65,000 hosts within it. A little bit smaller than this. And then when I get to the Class C addresses, I only have 1 octet left for host addresses, and I can only have 256 possible IPs here for each network. But I have a lot of possible networks. Here I have 32 times 256 times 256 networks, a large number of networks, but not many hosts within each one. And so what this all implies, Class A networks tend to be quite large, and there's not very many of them. Class B networks, there's a fair number of them, and they're quite a bit, they're still quite large, but they're not nearly as large as Class A. And then Class C, the largest number of networks within the class, but also the smallest size networks. And that's what all of this implies. Now, the other thing that we mentioned before was that an IP address is always coupled with a subnetwork mask. That relates to what we're looking at here with this division between network and host, because it's the subnetwork mask that tells a device, a computer, a router, any device that has to process this address, the subnetwork mask is what tells the device where the division is. Because we have to remember, we can look at this and see here, here, and here, but computing devices aren't able to do that unless we tell them how. The subnetwork mask is what allows us to tell a device that a Class A address will be divided here, network and host, Class B here, network and host, and Class C here, network and host. We can see this by looking at the default subnet mask for each one. So in the case of a Class A network, the default subnetwork mask is 255.0.0.0. Now it's also important to note this is not an address, it's a subnetwork mask. And so what this shows us, if we look at this, we notice 255 here, rest zeros, and that difference is right where we know the division is between network and host.